right, now that everything's working, I am happy to welcome you all here at the Collective Incubator to the Siemens Research and Innovation Ecosystem Conference. We are very happy that all of you made the way to the Collective Incubator or joined us online. And I want to especially welcome Dr. Peter Körte, Chief Technology and Strategy Officer at Siemens. We are especially happy that you made it here today, so welcome to you. And today is the second part of the conference with the topic Sustainable Energy and Infrastructure. Yesterday, the attendees had already exciting insights on grids and buildings of the future by Siemens executives or RWTH Aachen University professors. PhD students presented their research topic and a lively panel discussion took place. My name is Brenda Ritter and I'll be guiding you today through the event. I'm 26 years old, studying business administration in my master's degree at RWTH Aachen University, and I am the chairwoman of the Collective Incubator Association, your host today. We are very happy to have the opportunity to host the event here with us today, and so we can contribute to the inspiration in the fields of sustainable energy and infrastructure by leading experts. Today, you can look forward to tech talks on the question, are our grids and buildings ready for a fast energy transition? This is going to be followed by a young innovator panel discussion. So please join me now in welcoming today's speakers, Raifa from Technical University of Delft, Matthias Schnieders from Siemens, Marco Wirth of RWTH Aachen University, and Erik Brümmendorf from Edifion. Great to have you here with us today to give us your insights into how grid and building technologies can be intelligently combined for a carbon neutral and energy saving transition. We want to start with Marco. He's working at the Institute of Energy Efficient Buildings and Indoor Climate at RWTH Aachen University, and he's giving us an introduction on how buildings can be decarbonized from a heating and cooling perspective. There you go.
All right, thank you very much. I hope that the technique is working. Yeah, let's see if my presentation is there. Perfect. So I will give you today an insight from the heating and cooling perspective on the energy transition, because that's like the PhD topic, what I'm doing for 5 years now at the Institute for Energy Efficient Buildings and Indoor Climate. And I want to dive into it with a cartoon that I really like. It shows a bit the energy transition and the players that are involved in it. Like many people or different people are involved, and some are going for batteries, some say we need green hydrogen, others say we need electric vehicle, and so on. All these aspects are very important, that's for sure, but one aspect is very important to achieve and crucial to achieve our climate goals, and that is the heating and cooling sector. Just to give you one number, the heating and cooling sector in the European Union accounts for 50% of the final energy consumption. And if we want to achieve our climate goals, then we need to decarbonize the sector very efficiently. And that's what I'm going to show you today a little bit. So obviously we are leaving the era of fossil fuels and gas and oil boilers, and we are entering a new era which will be dominated by two key technologies, and that's a heat pump and a heat network. And I just want to give you a short introduction into it for the ones who are not so familiar with it. So the first key technology is the heat pump. And the heat pump, just to give you a short intro, uses or transfers heat from a low temperature reservoir to a high temperature reservoir. So for example, from 8 degrees Celsius to 20 degrees Celsius. And we are using electricity for that, of course. So that's the link to the electricity grid, so to say. And for about 4 kilowatt hours of heat that we produce, we need 1 kilowatt hour of electricity. So the good thing is that we all have a heat pump inside or at home already. That's great. If you don't know this, I will show you. If you have a look at your kitchen, we will find a fridge there. And the fridge is nothing else than a heat pump, because it transfers heat from 8 degrees Celsius, more or less, to 20 degrees Celsius in the kitchen. So that's like a tiny heat pump, and we know the technology, and it's working pretty good normally. So of course, to heat our homes, we don't need a fridge, but we need another heat source, and it could be, for example, geothermal boreholes, but it could also be like the ambient air that we are using, and we transfer the heat from the low temperature reservoir to the high temperature reservoir. All right, that's the first key technology, the heat pumps. The second key technology, in my view, are heat networks. And heat networks are used to distribute heat from a heat source, from a single heat source, to buildings. And this technology is used now for more than 100 years. And we use the steel pipes normally and transport water circulating in the steel pipes with 80 degrees Celsius to the buildings. We heat our building, and then the water is returning with, for example, 55 degrees Celsius. And these pipes are buried in the ground. So in the next couple of slides, I will show you the combinations from heat pump and heat networks that we will use in the future to decarbonize our building stock. And I thought, okay, it's a tech talk, so I can be a little bit more technical here. I made up this grid, and I think there are the three most important system configurations, how we can decarbonize our buildings. And the first one is on the top left. It's a building heat pumps, so heat pumps in every building, and we don't need the heat work for the first option. Let's dive into it. That's very straightforward. I already showed it, basically. So we have a heat pump inside every building, and we are using a heat source like geothermal borehole or ambient air, for example. The disadvantage about this system is that we have to plan a heat pump for every single building, which takes a lot of time and a lot of engineering work. So this is a good approach, but there are also disadvantages connected to that. The second one is the one on the bottom right. That's where we use a central heat pump, for example, and a heat network. That's also something, which I almost showed. So we use a heat network and distribute the heat from a single heat source. And we have a central heat source. In some cases, we don't need a heat pump if we have, for example, high temperature waste heat from an industrial site. But in many cases, we will need a heat pump, for example, if we have a borehole heat source. And so there's also disadvantage with this solution because we have heat losses in the heat network. So we are losing 10, 15, sometimes 20% of the heat to the ground, which is not so optimal. And the last option, maybe the most interesting one, at least for me, because my PhD topic is about this technology, is that we are using building heat pumps and a heat network. And in German, that's called kalte Nahwärme or Energienetz. And in English, the term is most of the time fifth generation district heating and cooling, and that was my PhD topic. And the idea is that we have a central heat source, like borehole field, for example, and we are distributing now the low temperature heat, like 6 degrees Celsius, to the buildings, and we have in every building a heat pump. So which then raises the temperature. And there are a few advantages connected to this solution. The first one is that we don't have any heat losses in the grid. So actually we have heat gains, because if you imagine that the ground has 8 degrees Celsius and the network has maybe 6 degrees Celsius, then we have a heat gain in the network. We can also we don't have to use these steel pipes, which are very expensive and difficult to install. We can just use plastic pipes that we know from the water supply networks. And also installation is very cheap, which makes it very easy, fast, and a pretty cheap solution. The third advantage is that we have a central heat source, so not every building has to plan their own borehole field or borehole solution. But we have one central heat source where we can just drill 100 boreholes and then supply the whole district with it. And the last option, today it's not so important because it's very cold outside, but in summer we are sweating a lot in the buildings. And with this solution we can also provide cooling, which is very good because we have a low temperature, 6 degrees Celsius, for example, and then we can provide cooling and we don't have to sweat so much in summer. So these are the three options which are, from my perspective, the most important one to decarbonize the building stock. And some of you may now say, wait a minute, I want hydrogen. Where's hydrogen? Or what about biomass? For sure, biomass and hydrogen and so on will also play a role in the decarbonization, but from an efficiency point of view, like a thermodynamic point of view, normally it's more efficient to use a heat pump and not burn hydrogen or burn biomass. All right, so one insight what we are doing at our institute and what I'm doing simulation and optimization models for these thermal networks, and we are building digital twins for it. So we are actually building the network inside a computer, so to say, and we can simulate it and have a look if the dimensioning is very good or not before we actually build the system. So that it's a big advantage that we can really go into the details and analyze the system before we have to build it and then maybe find that something is not working. I don't want to go into the details about the thermohydraulic simulations here. I just, I could also like finish the talk at this. That's an alarm day. I like it. It's almost perfect timing. That was a great pause. Now I can start with the second part of the presentation, because I was about to finish, but due to the alarm, I will continue a little bit more, because this is not the thing which the engineers outside are using normally, because most of the engineers are not experts and they are using just Excel sheets or some very basic calculations, and they are not using the thermohydraulic simulation, which are very complex. So I had the idea to create a new software, and this software is called NPro. And NPro is a planning tool for districts and heat networks. It's available on npro.energy, and the idea was that that this solution, that the software has 5 key advantages. It's a software where you can, which you can use in the early planning phase. So if you don't know, should I build a hydrogen solution, should I build a heat network solution, then you can use the software to figure out what's the best option in the early planning phase. It's a web tool, so you don't need any installation. You can just go to the website and use the tool. It's very intuitive and fast, so also non-experts can use it at municipalities, for example, has a user-friendly interface. But still, although it looks pretty easy, it still has the complicated, or kind of complicated IA-based dimensioning algorithms that we are using and developing at the university. And just to put it on a 2D chart, so make it very easy, the academic tools are pretty smart and pretty complex, but they are also very hard to use that we are developing at university. Then everyone else is using Excel spreadsheets, which are kind of easy to use, but not really smart, and they are not detailed enough to really calculate the systems. And NPro was a solution that I came up with, which is really easy to use and almost as smart as the academic tools. And yeah, here just to give you an overview, that's like how it looks like the dimensioning algorithm, for example, where you can really click your system that you want and then ask the tool, okay, what's the optimal sizing of the system? How much battery capacity do I need? How much PV do I need? You have the trade-off between CO2 emissions and costs, and then you can select a system that you want, depending on the optimization results. And in the second step, for example, you can simulate it, and after 30 seconds, if it's going good, then you get already an overview about the energy flows in the system, how is the author key grad and so on, and also download the results and have a look at the economic results. So that's like a very easy and direct approach to it. Just to give you an overview who is using our software right now, we have currently more than 100 academic users worldwide. We are offering this with a free license for universities, so all the students who are here can just use it for free. And we have more than 50 companies who are using it with a test license right now, and first commercial users from Spain, Germany, and Austria. So yeah, last slide. We have big plans for 2023. We want to develop the tool even further to make it even more advanced. We get a lot of feedback from academic community and also industry partners who are helping us with the development. And we want to develop a version 2.0, which is then even more useful for decarbonizing our buildings in the next 20 years. Thank you very much.
Thank you very much, Marco, for these exciting insights and the short introduction to NPro. We are now looking forward to Erik, product owner and co-founder of Edifion, and he will introduce us to his vision of developing a grid-to-building interface to us.
Thank you, Brenda. All right. Thank you very much. Nice to meet all of you. I hope we can talk afterwards, but first let me show why I'm talking here. Well, I'm 34 years old by now, and global warming has doubled ever since. And the main reason is consumption of fossil fuel, and there are so many instances. All right. So many instances telling us to act now. Club of Rome, IPCC, Al Gore, Fridays for Future, the war on Ukraine, but nevertheless, energy consumption didn't stop. But why is that? Pretty much they didn't answer the question where to start. Let me try to give you my answer on this. I got the introduction. I'm one of the co-founders of Edifion, and what we do, we separate the big part of total energy consumption to the building sector, and we focus on non-residential buildings. And there are 3 levers which we can touch to reduce carbon emissions on the building sector. And the first lever is optimize building operation. And this is where we start. It's 40%, which is possible just by using what's there as it's planned to be used. And this is where we start. So we came up with a technology which connects on the first-hand side to the existing building automation networks, takes all the data from the field level, which is going to be sensors, actuators, and so forth, and we historize those ones on our cloud service. We have a streaming connection, so we're talking microseconds of data transfer from the buildings to our servers. And, well, in a regular building, it's about 15,000 of those data points. So the technology is there to work with this kind of data. So part 2 is to analyze this kind of data. We have digital twins which structure this data and interconnect what, for example, belongs to a heat boiler or heat pump, as we have just heard. And we have algorithms which will identify faulty operations. This is going to be a level which will save us up to 50% of energy in a regular building, for example, like this one or any other university building. Part 3 of our technology is control. We are able to remote control buildings from our servers, so we can introduce model predictive control. Yes, it's a tech talk. I hope you heard it before, but we come back to this later. We are able to introduce model predictive control into buildings. So this is another 15% of energy savings we can realize. And as we heard, it's always tricky to have an easy-to-use interface for complex technology. Marco, thanks for the pre-talk. So this is why we came up with a sleek user interface. We address the different stakeholders in the buildings, which are the owners, the asset management, so to say, the facility management, the technical building operators, and we have easy access to their data, which we, as already mentioned, sort in digital twins, which structure the data points in between, and we have ongoing algorithms which are continuously analyzing this operational performance of those digital twins, and we are able to control all in real time. Many of this is powered by artificial intelligence, which is kind of a black box. So what we do, we also provide deep insights and KPIs. So it's not a black box for the technical building operator. They keep in control of what's happening in their building. It's working quite great. So 40% saved. So there are two different other levers. One is going to be retrofit and build measures. I'm not going to talk about this, but I continue with the part residual energy load. We just heard that heat pump technology is one of the main topics to decarbonize thermal energy required in buildings. And this is where we continue. It's not only the hardware, so to say, the heat pump, which is required, but also the control. And this is how we come back to model predictive control. So you see in the middle right here, the circle of data, which is already realized. We get data from the buildings. We have our algorithms which analyze what's happening there, which is training self-training the models about the building performance. We have, of course, the control optimizers running there for model predictive control, controlling the actual building behavior. We take into account external forecasts, and this is the part where the grid and the electricity grid comes into account. The more precise we would have load prognosis about renewable electricity in those networks, prognosis about the CO2 factors, we can consider it in controlling our buildings. This will enable, and we showed this in research before, that buildings become an active part and participant of electricity and electric grids. So we can combine, since we have cloud technology, several buildings. One is too little, but several buildings, and we can talk about buildings becoming virtual power plants then. So there are many buzzwords coming with this, with peak shaving, which is kind of realizable with only this part of it, up to load shifting, demand response, demand side management, and so forth. But what's behind this? Let me give you a high level, I hope, easy example. So on the left-hand side, this is pretty much how we control buildings right now. Even though if we have a heat pump there, we will control this heat pump heat load driven. That means whenever I need heat in my building, this heat pump gonna start running, and it will be running completely independent of what the CO2 emission factor of our electricity grid provides to us. Basically, it's during the night times, which is the time where we have little to sometimes even close to zero renewable energy in our grids. With a model predictive approach I just showed you, where we can consider load predictions in our networks, we are able to shift the schedule of the heat pump running times, the schedules of it, to the areas and time spans where we do have high amounts of renewable energy available in the grid. So this is the part where we can actually reduce the footprint of the residual energy. So we have two very close to control of buildings levers, how to reduce vast amounts of CO2 emissions. So that was a little bit too far. And of course, it's not only me providing this vision. By now, we have 50 people who are building this vision, making it become reality more and more. And we are as well founded here in Aachen from the chair of efficient buildings. Marco has just provided us insight into it. I never had a better speaker before my talk. We were founded 5 years ago. We also won the RWTA Spin-off Award. And yeah, we are happy that we are online with more than 100 buildings using our technology, actually saving CO2 right now. So I want to welcome you all to join our vision and get involved. Either you work on research and development, so please have a look at how to get this grid and building interface ready, how to get these predictions available via API. Digitize it, please. It's very urgent that this is going to be happening soon. Or just come ahead and join us building this technology. I'm really, really happy if you do so. Just talk to me and meet us in our office. We are situated in the middle of Cologne. And of course, remote work is possible 100% in case you want to live in Aachen. Thank you very much for your attention.
I guess we have time for 2 questions, I think, because actually the time schedule is not that tight. So yes, go ahead.
I can just ask one question. Eric, thank you so much. This is great. Actually, it's 1.5 questions. One of us is all of the building operators, they use already a lot of software, so now now they want to so why would I? The second one is why would I do this? Why would I do this outsourcing if I can, let's say, have purchasing contracts where I just buy 100% renewable energy and therefore I just don't care because I say what's coming to the grid is coming to the grid.
Yeah, good question. And of course, there are 3 stakeholders which are interested in this. Yes, operators. Yes, they do have tools. Yes, they normally have building management systems which sometimes have historical data available, and they have to do their analysis in case they want to go beyond the alarm they just had popped up every now and then and every time. And they get tired of those alarms, so they're never going to go back to actually fix, what's behind it. So they react. And what we are suggesting here is a solution which put them into the place so they can, well, missing the vocabulary there, agieren, like they can fix the behind problem, which they can with historical data, with a lot of time and a lot of expertise themselves, of course. But they just don't do it because they don't have the time. Sometimes they even don't have the expertise. So they have a tool which will do this for them. That's the analysis part. This is technical monitoring, basically. Why will they use it? Because it saves them time, because they are in charge of providing sufficient energy supply for the people working, living in the buildings. On the other hand, we do have facility management, which also are interested into this kind of energy decarbonization part. Why are they interested in it? Because they have, some of them have already contracts from their asset management, from the owner, which they have to fulfill. They have to give reports how they reduced the carbon emission of the building. And why is it interesting for the owner to do so? Because at least in Germany, they're not paying the energy bill, right? It's interesting for them because most of them are collected into capital investment funds, which are by the European Union obligated to get a certificate for sustainability in case they want to trade this fund as a sustainable fund. So all of you guys, in case you have too much money and you want to invest in stuff, please invest into ESG funds because it's sustainable, right? And those owners who have buildings invested in those funds or funded by those funds, they have to provide measures how to reduce the carbon footprint, and that's the low-cost version of it. Because each measure, the first 40% are none to low-cost measures, actually. That was a long answer, but to fulfill your needs. And the other half question?
The first one was making software, the second one is just purchasing contracts and then the reduction of energy supply.
Okay. All right, thank you very much, Erik, and also thank you for the interesting question. We will now hear from Matthias, Power Technologies Consultant at Siemens, about the transformation of energy infrastructure and his view whether grids and buildings are ready for it.
Hello, everybody. I'm Matthias Schnieders. My department is PTI, Power Technologies and International. So we are consultants for the electrical infrastructure. Our customers are the transmission grid operator and the distribution grid operator, and also the Siemens Energy, They build new power plants and the HVDC. Yeah, and we are 50 engineers in the headquarters in Erlangen and 100 engineers around the world in other office, Saudi Arabia, India, USA, and so on. Okay, and my topic is the transformation of the energy infrastructure. So we have many global trends and crises, and they have a big impact on the energy infrastructure. For example, the climate change, the digitalization, the demographic change, the urbanization in the Asia and Africa. So in Africa, for example, many of the people have no power supply of the electrical infrastructure, and so on. And the demographical change in Europe, the population are older, and so on. And this is a reason why we have a transformation of the infrastructure, and we are in the middle of the transformation or at the beginning. So in the next year, we have the decarbonization of the power generation, and we have the electrical consumption is twice or is very increased in the next year. And yeah, and also the smart meters in the households and in the industry is also an impact. So we have many sectors. They have one are the new sectors, for example, the transport sector, e-mobility, and the other one is the smart cities or the industry. And we should bring together with the electrical infrastructure. And also the renewables. We have the offshore wind parks. They have connected to the transmission grid, but also we have many decentralization, small wind farms onshore or photovoltaic on small houses or on green fields, and these are connected to the distribution network. And also we have some consumers, e-mobility, the heat pump in the buildings, and the goal is to connect this new consumers and generators together and make the grids the stability, and we have no blackouts. So here we have these different sectors, and we need storage, the renewables, the strategic distribution grid planning, the smart city, and so many topics, new topics and old topics, but we bring all together in the grids. And one solution of this is, for example, at the moment, we have the grids or the status of the grid. It's maybe a black box, and we should have a white box. So we need measure and observe the grids. So we need measurement points in the grids. For example, the low voltage level is complete a black box, and the higher levels are, we see the current, the voltage, the frequency, but that was all. And we need more data. And then the second one is that we need a digital twin of this networks. And also we need AE, that we have to handle the big datas and then we have the values to control the grids. And in the assumption of that we have so many datas, we cannot make it by the manpower, because we have not. It's very fast that we should control it, and it's it's very big data, and we should have this for the AE with a neuronal network or machine learning. And one big problem at the moment is cybersecurity, because electrical infrastructure is a critical infrastructure, and distribution operators or the transmission operators are very, they are not so, they are a little bit conservative, because cybersecurity is a big topic in this, and so this is a big challenge to combine the measure and observe data processing and also the control. So the technology is already done, or we have the technology, but we should bring the technology in the grids and make the grids to the future. Okay. Anyone questions?
Are there questions from anyone? Now we have a second microphone, so also the people in the live stream could hear you. So now would be the chance. Okay. So many thanks to you, Matthias, for the interesting perspective. And now we will conclude our tech talks with Raifa, postdoc at Technical University Delft for distributed systems and intelligent electrical power grids. And she will introduce us to the importance of cybersecure and resilient control of distributed energy resources.
Hi, thank you so much for the introduction. Thank you so much for joining us here. My name is Raifa. I'm currently a postdoctoral researcher at TU Delft. I'm part of the IEPG section, as well as the Delft Blockchain Lab, which is TU Delft Blockchain Initiative in terms of research around blockchain and, broadly speaking, trust within the internet. So my presentation today would be briefly walking you through the research I'm currently conducting, which is about the potential of using blockchain as a technology in order to enhance the cybersecurity as well as the resilience of the control of distributed energy resources, specifically within the residential areas. So the outline for the presentation is the following. I'll start with some context, what's happening so far in our energy systems in terms of the net zero goal that we are trying to achieve, as well as the PV's growth worldwide. Then what are we actually missing from this, which is basically cybersecurity. As we move with the digitalization and having more edge intelligent devices, this basically increased the attack entry point. And I would argue here in this talk that basically blockchain could have the potential to address some of these cybersecurity aspects. And then last, one legitimate question to ask is, would it be enough? Well, we'll get to that by the end. So starting with DRs, well, with some context here, we all know that the Paris Agreement is an international treaty that it was, I believe, signed in 2015 or something like that. So the goal is basically to tackle climate change, and among the initiatives that were taken in order to actually reduce our gas emissions by 45% in the next decade and reach ideally net zero by mid-21st century. And among the initiatives taken worldwide to achieve this goal is basically the proliferation of distributed energy resources that are defined as small-scale power generation, also storage technologies with a capacity that could be around kilowatts or maybe around several megawatts. Those could be either solar panels, wind turbines, small ones, batteries, fuel cells, even EVs and their charging infrastructures are also considered DRs. So here the focus, I would say, is on PVs or solar panels. So what you see here is a chart that was taken from the US Energy Information Administration report that is depicting the growth of the types of renewable energies. So here the focus on PVs basically share, it is expected to count for almost 62.3%, and it already, the additional capacity of just distributed PVs was around 60.7 gigawatt in the last year, and it's expected to be around 71.1 gigawatts. So if we focus on just PVs and consider distributed ones within residential areas, rooftops and all of that, so their share is basically growing. But the problem is that we don't really know the impact they would have on our grid, because basically they would be connected. So here, speaking of that, residential rooftop solar panels could be functioning following a self-supply, in which you have the energy generated by those solar panels feeding the load of the household, or they could be also connected to the grid, and that's where you have the grid supply. But the problem here is that having them connected could actually cause the voltage as well as the frequency to fluctuate outside the required levels within the international standards and several grid codes here. I think that's the German one. And also, one thing that I believe Matthias also mentioned is that currently in terms of advanced meter infrastructures, I would say those are well established. But what's behind the meter in terms of DRs, well, basically the DSOs don't have any visibility in terms of that. So we need almost near real-time monitoring in terms of voltage control, and also a secure control of those DERs in terms of the active and reactive power set points that they would be getting, in terms also of their inverters and their primary sit-ins. And speaking of cybersecurity and the security of these controls here, well, basically DERs are connected to the public internet. It's within a house, and this house is connected to the public internet, which is different than bulk generators. So therefore, you have an insecure connection, which makes it vulnerable to man-in-the-middle interplay attacks. Then also, in terms of the distributed denial-of-service attacks, that would affect the availability of these DRs. And then last, we have a lack of tamper-proof auditing as well as logging of all these DRs that could be seen as the grid assets. Then here, to assess the potential of one attack on these DRs, so we use the IEEE European test feeder, which is basically a 3-phase radio feeder. It contains 50 households with some PVs. Actually, it does not contain PVs, but we added some PVs with capacity equal to either 1.5, 2, or 3 kilowatts. So what you see here is the aggregated load as well as the generation from those PVs. So during a sunny day, basically the generation exceeds the load. And here you see the voltage magnitudes of all the households which are connected to phase A without any PVs. The voltage is contained within the limited values. But when you add actually PVs with reactive control, you can see that the voltage in the midday actually starts increasing, but it's still contained. But if you actually reverse, because the thing about DRs is that if they are equipped with smart inverters, so those actually are having local control, which is based on a curve. So if you basically inverse that curve in a sense, when you need to actually absorb reactive power, then therefore you would have, like you would be injecting it. So therefore that would impact the voltage magnitudes, and you can see here that it's actually beyond the acceptable range. Then the goal here is to basically use blockchain. So the natural thing to do is to see what has been done so far, I would say, in the literature and a little bit in the industry. And that was basically the focus of one survey that we recently published. So you see here the publication of blockchain-based applications for smart grid in general, not for DRs, between 2017 and the second quarter of 2020. So here, one major thing we've noticed is that blockchain was mainly used for energy trading, which is basically expected because it's, before anything else, it's a crypto peer-to-peer cash system, so therefore using it for energy trading makes sense. But the question is, can we go beyond that? So here, speaking of energy trading, one project that was in the Netherlands is the Juliet token, and also the Publis project, which was by Siemens, I believe. And then here, the second graph is basically the evolution of the trend. So basically, you can see that the energy trading is still the highest one, and also the privacy concern is catching up, but cybersecurity is just only for 2%. So that only shows the unexplored territory that blockchain could actually offer. Then here also another aspect, because we are trying to use blockchain for controlling DRs, basically roughly speaking, there are two types of control. Either you have centralized based control or distributed, and blockchain falls within the second one because it's a distributed ledger. So for decentralized control, basically you have one central coordinator, which is basically ensuring the optimal coordination of all those DRs. It has a complete system overview of what's happening in terms of the measurements, and also it has the exact information in order to achieve the local as well as global objectives. The problem with decentralized control is that it might reach the limits of its scalability, because you would have more DRs and therefore more data transferred to that central controller, and that would increase the computation complexity, and also you would have the communication overhead, and also you would have a single point of failure, which we would like to avoid if you seek in resilience. So distributed control has been regarded, I would say, in the literature, I'm not sure in the industry, as a plausible alternative. So basically it is characterized by the absence of a central coordinator. You have a robust and flexible architecture, in the sense if one of the agents actually falls or is faulty, the others can still operate and operate the grid in a stable manner. And then we have also parallel computation, and there also less communication overhead, because you would have the just neighboring data which is traveling between those DRs, and that's it. But the problem with the distributed control is that it might not achieve the same performance as a centralized one, and that's due to the number of iterations that the algorithm has to go through before reaching an optimal state. And then we also have the problem of having constrained edge devices. Therefore, and also the need for reliable peer-to-peer communication. If one of these agents is actually faulty, and because we said that we only have exchange between neighboring data, so if one is sending incorrect data, that would cause the algorithm to diverge, so therefore you would not get an optimal state. And also the problem of having DRs that are geographically very dispersed within the low voltage network. And here, the idea is neither going fully centralized or fully distributed, but more or less a hybrid architecture in which you would have each layer being distributed, and then as you go higher, then you would have a clustering which is running in a centralized way, and the infrastructure of that is going to be built on top of blockchain, of a blockchain network. And then here, by using blockchain, you would have the integrity of the data, and that's due to the hash functions. Then security due to digital signature algorithms that are deployed in the technology, and then a certain degree of automation by using smart contracts. So an overview of the architecture, you would have the low voltage here with a couple of DRs scattered. So the idea is to segregate the low voltage into blockchain zones. So network segmentation is actually important, because if an attacker is just within that segment, it would stay within that, so it would not affect the others. And here, you would basically have all these nodes that are part of the blockchain. So we would have the admins, which could be DSOs or TSOs. Then we would have the aggregators also. Then the DRs themselves are going to be nodes within the blockchain. So this whole thing is going to be constituted the peer-to-peer network. And then for the control logic, it's going to be implemented within smart contracts. So that could be in terms of your voltage control, software control, for the DRs, etc. And yeah, for future perspective, and going back to the previous question that we actually asked, it is going to be enough. Well, blockchain is not the solution to all problems, although it addresses some issues, but it's not going to be magically solving everything, to be honest. So here, the problem is that blockchain itself is still having some challenges in terms of its scalability as well as the ledger overhead. Then you also have the possibility of combining this blockchain infrastructure with other AI machine learning intrusion detection systems in terms of the measurement data, so that you would know whether you have a false data injection or something. Then one issue that might also arise is the interoperability of this infrastructure with other SCADA tools that are used within the DSOs. This could be actually tackled, but it's still a challenge that needs to be taken into consideration. And then finally, we have the governance and the incentives. So things could work on paper, but implemented in real life is the real challenge. So here, the idea is to have a consortium blockchain in which you have the DSOs, TSOs, the manufacturers of those DRs, or whatever, part of this whole blockchain. So there has to be a clear governance of this infrastructure, who's going to be having access to what data and all of these things. And also there has to be an incentive. Why should they join that? If there's no incentive and if it's not in their own benefit, no one would be part of this. So each one of these is actually going to be a topic of itself, but those are basically the future perspectives, and that's it for my presentation. Thank you so much for your attention, and
questions? Yeah.
Is there a place on Earth where you would say this is really already there, or at least in a pilot project where you're getting closer to this, what you just described?
sorry, can you please repeat? I couldn't hear the question.
Do you have an example somewhere on this planet where this is already, now some of the elements are already implemented?
I would say,
What's the furthest?
as far as I know, not in terms of the control.
Yeah.
Like in terms of controlling DRs, no.
No.
Just in terms of like exchanging energy, you know, peer-to-peer trading,
that's fine.
blockchain has been implemented so
That-
far.
that-
But for the control, I
Yeah.
don't think so.
Okay.
Maybe in the literature you would find some papers who hinted on that, but still I wouldn't say it's there yet.
So still we need a pilot.
Yeah, that's the goal actually, what we're trying to do at Child, like having a small prototype or something of that, so that we would test it and then combine it with other technologies and tools and see if it works. And
Cool.
yeah, that's the goal.
Very good. Can I
Okay, thank you.
Does the blockchain network include that every participant takes part on the spot prices of energy? So do they trade the energy on spot prices, or do they have a contract with a fixed price?
Oh, well, no, we're not actually working on trading energy.
Yeah, but the energy, the blockchain network exchanges energy inside, right?
What do you mean by exchange energy? Like the energy generated from the DRs, or?
Yeah, because the energy is like compounded in the network. Or sorry, maybe I was.
Just define which energy you're talking
No,
about.
so the participants in the energy network,
Yes.
in the blockchain network.
Yes.
Sorry, is it necessary that they have contracts to trade energy on the spot prices, on the live prices?
That's the thing. Our work is not on the energy exchange, although that's already
But
established.
it would be
yeah, sure, you,
benefits,
yeah,
right?
you can indeed combine this infrastructure with peer-to-peer trading, and therefore for that you have like, it depends. For some cases, each prosumer would have his own contract, which dictates the way how he's going to be trading his energy, or sometimes you will have aggregators, and then there are the ones aggregating all this generated energy from those DRs from the prosumers, and then the contract is going to be done with those aggregators rather than the market directly. So there are different types to tackle this energy exchange. So that's a different topic, but still it could be combined with this whole infrastructure. Okay, thank you. Any other questions?
Yeah, anyone else? Okay.
More? I'm getting a lot of questions. Should be happy about that.
Yeah, really cool talk. Thank you for that. Does the blockchain solve any other issues but the missing trusting authority after all?
Trust in what?
Trusting authority. Because
Yeah, basically you have this, the idea of blockchain is that you do not have a trusted third party. So here it's having more of a consortium. You have different entities, but none is having full power over the system. Because you would still need that. You can't just go let people trade with like their energy or control whatever what without having like the DSOs part of that. Because after all, those DRs are connected to the grid. Who's managing the grid? Let's say DSOs, TSOs. So they need to be part of that. But then while having your blockchain there, you would still have all actions going on and written within the ledger. So each one is going to be held accountable for all the actions. So it's more of like a consortium rather than private blockchain or fully public blockchain. So it's something in the middle.
solving the trust issue.
Yeah.
Well, I would love to talk to you about the interoperability issues with the SCADA system, but maybe let's
Yeah,
move
sure.
it
Definitely.
around.
Thank you.
Anyone else? Okay, perfect. Then thank you, Raifa. I think that was a great finale on our tech talks about our grids and buildings ready for the fast energy transition. We have now been able to already gain some insights on sustainable energy and infrastructure. And yeah, we learned about some different approaches, and I would be really happy if you, maybe there are some questions afterwards, just save them. We have some time for networking afterwards. But now we're just going to take a short break, and then we will continue with the Young Innovator panel discussion, and it starts in about 15 minutes at 12. So see you soon, and use the time for some networking. innovation. So all our offerings come from students for students, and we believe that this is the great advantage of the collective incubator, because we are able to put ourselves in the shoes of potential founders or idea holders, and thus we can support them in the best possible way. We started a few years ago with a small pop-up, also here in Aachen, and now we are today here in our 4,000 square meter premises. And yeah, this is just one reason why I am very proud to be part of the project. I think we've already come a long way, and we have 40 dedicated members who strive every day to support our communities, to develop more offerings, and yeah, just support them with their ideas and their founding. When I say community, this is 190 teams, startups and student initiatives, and in total we already help 2,000 individuals with our services on innovation, entrepreneurship and networking. Our services include, for example, free and round-the-clock use of these premises. This means meeting rooms, but also flexible workstations. And some startups are very lucky because they have their own office here with us. And in addition, we have some small services, just like van rental service or film studio that can be rented to produce own recordings. And I already mentioned it, our makerspace, not to forget, our teams can use it to produce prototypes. And all these services and all our work are we doing to support these bright and young minds in their idea generation and implementation. This is also why we are very happy to be a part of today's event, and we want to support the opportunity to gather inspiration in the field of sustainable energy and infrastructure, as well as the combination of grid and building technologies for carbon neutral and energy saving world. So thanks to all the leading experts who are with us today and sharing their insights on their topics. Now I would like to hand over to Niels, who will moderate the Young Innovator panel discussion with our speakers, Raifa, Matthias, Marco, and Erik. Enjoy and thank you very much.
So, yeah, you may come to stage if you want to, and then we'll start. Yeah, and once again, welcome from my side. My name is Niels Körber. I am research associate and PhD candidate at RWTH Aachen University. I'm working at the institute, which has quite a bulky name, which is called Institute for High Voltage Equipment and Grids, Digitization and Energy Economics. We basically do everything in the energy field. Our DNA is normally from the electricity sector coming, but since the world is becoming more connected, more multi-energy, we also look at heat networks, at gas networks. So we basically combine everything in the energy system. And yeah, there in my position at RWTH Aachen, I'm group lead of the so-called group Distributed Flexibility, where we look especially at municipal, urban energy systems and look there at the transformation. And yeah, that should be all on me. Now the highlight is on those 4 people, the experts, which gave already some very nice introductions to their topics, on their visions on a climate neutral energy system. And yeah, I want to focus on that a bit more with you and share these visions with you. So we've heard, and that is the connection to yesterday, that towards climate net zero, towards a sustainable energy system, there are quite ambitious goals. And I want to first talk about these ambitions with you. And starting with Marco, you already showed one major ambition, the sleeping elephant in the room, the heating sector. Can you tell a bit us more about these trends towards sector coupling and so on in this field, especially looking probably also on worldwide and socio-economical changes there? What are the major problems in your case?
So yeah, a big field for sure, and sector coupling is a big buzzword, but I think it's very important because well, I highlighted in the presentation a bit the thermal side, and this heat pump technology was always mentioned, and that's really the coupling point for me between the thermal supply and the electrical grids. And I'm not an expert in electricity grids, but there we always have the issues like if we are building a system, building up a district with a thermal supply system, what can what can we expect from the capacity of the electricity grid and so on. So yeah, I mean, the challenges are many, going from the technical side, like the heat pump things and so on, but also going to the manpower side, we have to decarbonize, I don't know, like 10 million buildings or something in the next 20 years. And this has to be planned, and we need so many engineering power for this. This is a problem on its own. So that's a very broad challenge landscape, so to say.
Let's look at our question. Are our grids and buildings ready for the fast energy transition? And you looked primarily on these buildings. You showed that there are technologies in field, and that is my next question to you. Do we already have all the technologies available for the fast energy transition, or do we need more? Do we need innovation in this field, looking at new technologies?
Yeah. Often I think actually we have already everything together which we need. We just have to build it and realize it, like heat pump technology. Okay, we can make it even better, and we can have even fewer percentage of the efficiency increase and so on. But sometimes I go over fairs and through fairs, and I see like new innovative products which you could not imagine. Like last time I saw like a thermal collector system which is really easy to install and everything even easier than now. But yeah, I think we have most of the things already together. We have to just install it. We have 20 years left, more or less, and we have to do it now. I think that's a very important point, and driven by the political environment. So we have to have the correct political decisions, that we have the good, how's it called, like subsidy programs, and then have the engineers who are building it. I think most of it we have together, but yeah, of course, it's always good to put some effort in research and feed the university so that we can come up with new innovative products as well.
Yeah, sounds like we need a new approach towards technological advancements, and I mean that's why we're here on stage, I guess, as electrical engineers, mechanical engineers. Probably there's the need for more, like building engineers and so on. And that is probably my next question to all of you. Do we need an interdisciplinary approach here? And what are the interfaces in this interdisciplinary approach we should focus on? Probably, I mean, you are doing this in your day-to-day work. Starting with you, Eric.
All right. Let me start with how far did we already go? Yeah, technology is ready. We are lacking pretty much the processes on the administrative side of building and portfolio owners to scale technology as we have. For example, saving the first 20% of energy just by actually utilizing stuff you already have in your building in a good manner. Because transparency is lacking, knowledge is lacking, stuff like this. All of this can be digitized, all of this can be scaled. Do we need more interdisciplinary work there? Yes, of course. But this is not only engineering, that's not only technology, but it's also legislation, this is administration, this is owner work there. I can go in very much detail there. How far shall I
go ahead.
How far shall I go? So
talk about your day-to-day business. What is the interdisciplinary approach there? What is necessary?
So what is necessary? It's always very easy to say more legislative regulation, but that's very slow. So it's about the mindset of people, of owners, of each of us to actually care about sustainability, not just building technologies which is ready for it, but also buying products which take care of this, or at least trying to, investing in funds which are ESG certified, which is meaning that in case there are buildings collected and capitalized within those funds, those people, those owners need to take care of sustainability, which is putting pressure up on the administrational part of it, which furthermore puts pressure on their own in-house IT technology, also building experts. And this is where technology, as Marco provided, as you guys provided, will come in very fast in this case.
Yeah, that's, I mean, a major point you put in here, the mindset. We're looking at IoT systems, and RIE showed us with the blockchain one of those IoT systems quite obviously, which will have a future probably. How do you see this mindset thing? Is it something which is lacking in the industry?
Well, yeah, I think like this whole IoT wave or era is already there, or like we're already witnessing like its impact. But the thing that I would like to pinpoint to is the cybersecurity aspect of that, because when you have more connected devices, just think of it within your household. You have this smart fridge, smart this, smart that, and all of that is connected. And there are several attacks that were there. For instance, the Mirai IoT attack that actually targeted some home routers. So the attacker could get access to that router within your home. So think if they can escalate the privileges and get access to other of your devices, which are maybe high wattage devices. So those could actually be used to, for instance, you can switch them on and off, and then that would actually cause instabilities within your grid. And there's basically one paper that was published that was explained in this whole attack. It's Black IoT, I believe, the name of the attack they give it to. So the idea is that you could actually have, if theoretically you gain remote access to those smart devices, then therefore you could have an effect on the frequency as well as the voltage of your grid, because everything is connected. And then also you have the smart inverters of those DRs. So basically if their software is not updated properly, or if you have like a port that is actually open, or maybe like even in terms of the protocols that are used for those IoT devices, some are not actually fully secured in terms of the encryption, the requirements for authentication. And then, yeah, it's several things that need to be, what we need to focus on is more like an awareness of that. I believe in terms of like industries, yeah, people are aware of the cybersecurity aspects. They have teams dedicated for that. When they design a device or something, they do it with like penetration testing and all of that. But when it comes to like prosumers, normal people, they're not fully aware of that. So that's something that we need also to consider, because you have your household building connected to the grid, and everything that's happening there could also affect the grid. So
like there is some lack on information to those customers to be aware of that. Probably looking at you, Matthias, in your day-to-day business, you work with grid operators, and they could probably be the ones to give this information to customers, but also their mindset has to be changed there, or?
Yeah, I think we have the technology in the hardware, and sometimes it's installed in the grids, but the function what the hardware can do is not running, or only a small part. And the big problem is the communication between the hardware. And the grid operators are very conservative in form from the digitalization. And I think they must open it, because if you have the unbalancing of the load and the generation, you should shift the load in other parts where you have the renewable generation, and this you need a communication between the load and the generation and the devices in the grid. And yeah, the communication is via the internet, and so the grid operators must be open and should make the digitalization in the systems.
Thanks. Let us get into a bit of the detail. We came from the grid, from the buildings. In the building side, we heard that technologies are available. So we answered a bit of the question, are we ready for a fast energy transition? In the technology field, we looked at what is about the workforce and what is with technology digitalization. And let us pinpoint that at the grids a bit. How far have we come in the grids? We yesterday talked about transparency of our grids, of energy flows. What are the crucial points here?
Yeah, also in the low voltage system, the operators have, it's a little bit a black box for them. They have no idea how many consumers, when they need the energy, or for example, the fridge or the heat pump, they run if the human said, okay, now I need the heat. But the operator don't know exactly at the time when they need the energy. So that is, and for this you need an automatic. The systems must be communicate, and the data working must be automatically without the human, and the customers, the humans, should have not an impact that no, for example, no, the heating it's not running, but so it's for me, for the human, it's no, it's okay that the heating is not running because the rooms or the houses are warm. So that is a solution.
Is it the same as in the building sector where all technologies for getting transparency, probably also the software is available, or is there the true innovation? I mean, we heard of Eric who had the innovation in this field in the buildings, and I think we will also look a bit deeper into that. The question is, do we also have these innovations on the grid side, and are they necessary?
Yeah, the ideas we have, and the software not to 100%. So we need more engineering in form of the software. But yeah.
So let's look a bit into the potentials, and that is for you a question, Raifa. You showed us the blockchain as a potential, and we talked already about piloting, controlling of those systems.
Yeah, that's
Are we
true.
at this stage, or probably at a stage before that, where we show the applicability of blockchain to certain systems? Since you showed data integrity might be a problem.
It's more about like showing that it's plausible to apply for this case, because as I mentioned, like if the idea is that you would have all this, the need for the data in terms of like optimization of that, if you want to record it, then you also run into privacy concerns. So therefore this data needs to be treated carefully. And then also what I would say that blockchain could offer you is more of like this framework for like auditing, and that everything is going to be transparent. So for the transparency, therefore blockchain could actually ensure that, but it also comes with other things that need to be addressed. So yeah, I believe there's still like a lot of things to consider.
So maybe one question to follow up this: do you believe in data integrity when end customers are there, when we have measurement units?
Yeah, I mean, you need actually to ensure the integrity of this data, because whatever optimization you'll be having in terms of the DSOs or the aggregators, if we take the example of like the DRs, so therefore you have the scheduling of those they had in the markets and all of that. So if the data is not actually reliable, if there is a fault or maybe a malicious entity, so that actually could impact those optimization algorithms or whatever software that you have. So you need the integrity of the data, but then also there is the balance of, okay, we need integrity, we need more data with like higher granularity, but the problem is that also the privacy issue, because there are regulations that maybe we can try to like walk around that, but it's still there and it needs to be considered. So it's a lot of work to be done, but I believe we can do it.
Okay, thank you. Let's connect this topic to the buildings, and that question goes to you, Eric. At the buildings, you showed us that transparency of energy flows might be given, especially in your non-residential buildings where you are focusing on. Probably you also need the measurements there. In which form do you need measurements there, and how do you get this visibility in the system?
Okay, in which form do we need it? We take as much as possible, of course. And in the non-residential area, it's quite easy to address the privacy issue, because you have single rooms which will be occupied by some people if you don't have the knowledge. So that's going to go, the knowledge who it is, that's going into the nitty-gritty, but we can exclude this from any data acquisition. And within those non-residential buildings, we have many, many entities which are publicly used by many, many people, so you cannot transfer it back to the single person. So this kind of data policy is not hard to address, actually. So we can take any data which is not correlatable to a single person, store it on our servers, and we need this data within a few seconds, time batches in between, so we can measure the whole system. That's enough for our systems. As soon as we go more into electricity, I think even higher frequencies are necessary, also possible with this technology. And the more accurate we want to go, the better is it to have shorter frequencies. And since the technology is there, we have those building automation networks where we get this data from in place for 20 years by now. So that's not new after all. The only thing which is new that we bring it to centralized cloud computing interface, let's say, which is capable of connect to any grid interfaces. And we can actually control those buildings in a way that we utilize the thermal inertia. Matthias, you just told us about. The heat pump can have a little flexibility to still provide the necessary heat for the room. As soon as this interface is innovated in a sufficient manner, it's quite easy to enable buildings to become grid active.
Yes, there's also the topic of scalability of such approaches. If we look at the building sector, it's quite heterogeneous. How quite custom fit are your solutions? Is this a problem? Do we need blueprints in the future?
Okay, scalability in the building sector is an issue to address, yes. And we were aware of this when we first started. So scalability in data acquisition is quite simple. We have standard protocols in buildings which are utilized on the, let's say, IoT field level of those buildings. And since it's just a few standard protocols, it's easy to scale the data acquisition there. The data structuring is another issue. So 15,000 data points, but you don't know what it is, because in some protocols there is the opportunity to use metadata, which bring the kind of data structuring directly from the field level, but mindset, remember, people didn't care about it a few years back. So although it's possible to exchange those metadata, they're not utilized in the way that we can use it right away. So we do have other algorithms, normally statistic algorithms, machine learning algorithms, AI algorithms, which classify such data points and enable a very fast data structuring on our platform. It's very easy to use, very fast to use, which speeds up this kind of data structuring issue. As soon as we got data structured, our algorithms are like from the box, just use it, reuse it, reuse it. Every building has a finite amount of technical equipment which is possible, and they all follow the same physics, they all follow the same technical routes, and as soon as you have algorithms ready for that, you can go. So we have for analysis, I think 113, 16 algorithms from the box. On the control side of it, it's a little bit more work yet, since you actually interact with the building, so you have to care a little bit more about constraints there. But it's also just a let's say, issue of the next months that every operator can use it himself or herself.
Okay, yeah, thanks. And it sounds quite complex. Looking from the building level to district level and the heating networks you showed us, and you said that's probably the next innovation step towards 5th district heating networks, cold district heating. Is it also a problem there? Might it be more huge problem, larger problem there?
Yeah, I think we are facing similar problems. Actually, we have, for example, I'm involved in a few projects where we are rolling out the 5th generation district heating and cooling networks on a district level with some industry partners. And it's not like a normal heating network, because we have the heat pumps, we have the signals, we have the temperature sensors, we have everything in there. So we have a whole bunch of data that we have to collect from all the buildings. We have to collect it, we have to gather it, we have to monitor it, and we have to analyze it. And that's the one direction. And then the second direction, go back to the heat pumps and tell within a district and tell it which heat pump should operate when. And that's a complex optimization. We have a bit advantage that we are not in such a high frequency, because we have this high inertia in the thermal networks. So for us, it's like 15-minute values or so are fine normally, at least for the thermal systems. But yeah, it's like I said, the sector coupling approach is very central. So now it's the heat pump, we have the PV on the roof, we have the battery in the buildings, we have the thermal network in the district. So everything is connected, and this is pretty challenging to build it up, and it takes a lot of time to actually make a plan how to set this up from a data measurement point of view, so to say.
Thanks. So as a synthesis of this question, you could say are our grids and buildings ready for the fast energy transition? We just pointed out that digitization, the mindset behind digitization, also algorithm software, is probably one thing we have to think about, and our grids and the buildings probably are not ready yet because of this implementation lack of those things in most cases. Let's connect it with the people behind the grids and the buildings. The people behind are the consumers, are the grid operators. We also heard platforms, platform economy, integrating users. What does it play to interconnect grids and buildings from your point of view? Are we lacking interoperability in this field? Can energy platforms help, for instance? Whoever wants to answer the question.
Well, yes, energy platforms will help, of course. Digitization means automation, and since we have a lot of, let's say, prosumers in the networks, the more we have, the more automation we need. So yes, platforms are the easiest way to go. There is a very, very simple way to interact with data. It's called API, Application Programming Interface. Any technician should know about it, which is basically a version which every company can design itself. Okay, then you need connectors once again, but it takes one time invest of 1 or 2 days to connect to another platform. It's not perfect, but it's working. It is, so it doesn't really take so much more. Actually, it takes very sufficient predictions, I think, especially if we want to go 100% of decarbonization, prediction for control decisions, predictions on the load, which we, as the building side, will produce. We need the prediction of CO2 factors, let's say, in networks, on electricity grids, and we can control the consumers behind it to a very, very high amount, especially for non-residential areas.
Yes, looking probably once more on the grid side of that platform economy, what is the value of that for grid operators?
I think that would be helpful for the transformation, because now the consumers are in form of buildings in the future, or now they are energy producer in form from photovoltaic in the roof or on the walls, and now they are consumers, and now they are both, and though I think the platform will be helpful that they can connect and
So normally we have platform operators. When we look at platform economy in the American states, it's an Amazon, it's Google, it leads to monopolies. What do you think will happen in Europe, especially in the systems? Are we adapting those systems? Will there be energy platform operators in the future? Might it be an Edifion? Will there be something more? Is it a legal issue we have to cover?
Oh, I just hold the mic, so I'll just continue talking. Stop me. All right. Actually, you do not need that vast amount of computational power. Yes, for modeling, yes, for predictive control, yes, but this is during the modeling phase, basically. So we do not need that really high potential cloud platforms as we need for, let's say, Netflix streaming. This is a complete different amount of data flows. So actually what we do, we have one computer for over 100 buildings. And this is not completely only our server. There are other computational stuff going on there. And the amount of computational power is that little that at least for the next few years, companies like us can just go ahead and rent easy access servers and put up our own software there. Of course, there are European initiatives like IRX, which are trying to do the hyperscaling part as the Americans do, let's say. Telecom also has a different project with this. There is open source software doing it. It's hard to answer, but what I'm very certain of is that there's going to be a cloud-to-cloud architecture, and it will be independent of the provider of the cloud.
Okay, yeah, thank you. That was what I already had in mind, because I mean we also need to gain access from somehow different persons, the citizens, the grid operators, and so on. So it's not the same customer for that platform in the use cases we see, right? And yeah, let's talk a bit about these use cases from the grid side and the interconnection to markets. Yesterday the question came up, how can buildings and grids interact intelligently? And there was the thing of markets, of market signals, but also legal things, which could assure that grids and buildings interact. What is your point of view on that? Maybe we start with the grid operator's side here.
Yeah, I think it's the right way that they should maybe in a big, not every building for each, but in the cloud, more buildings or regions that they can. I think this is a best solution.
Raifa, you talked about cellular systems, the system and the system approach and the energy system. Tell us a bit more about that, because I mean it's connected
just back
here.
to this grid and prosumers connection. I think I'm not sure about Europe, but do you have aggregators in which they are used for aggregating the energy from those prosumers, and then you would have that seen as your virtual power plant, and then those would actually participate within the markets, and then you would have this whole platform. There are already some platforms for that in USA. I'm not sure about Europe, to be honest. So that could actually be done. The thing is, you need to ensure, as was mentioned, is that not only prosumers are going to be part of that, but you have different access, so therefore you have different use cases, different requirements and all of that. So that also needs to be taken into consideration. And back to blockchain, could be actually used in that. You would have the blockchain infrastructure. On top of it, you would have this think of it as an application that is running in this distributed system, and then you would have this trade-in between all the entities and all of that. So yeah, it's a system within system, and also the aspect of aggregating or splitting your grid into zones, because you can't do that in the whole grid, and then you would have one single platform, one single person managing everything. That could not be done. So you might have aggregators between the prosumers, buildings, houses, with the DSOs in the grid, markets, and whatever what you have. So you have this hierarchical architecture, and then you split the lower zone into areas, and then the processing would be done within each zone, but then you would have the aggregation, and yeah, it's kind of this vibe.
Yeah, sounds like a quite complex system, and if we move towards more complex system, there's probably taking all the people here in the room, and not only in the room, but also in whole Germany, in the worldwide with us. And we need transparency for that, I guess. And that is my question to you, Marco. Transparency in the field, they are quite probably crucial for a fast energy transition, because if people don't understand, they won't act. What can we do? I mean, you have a product for that?
Okay, yeah, true. So it's transparency is a big issue to get the people involved, to get them actively involved, for building it, for accepting that the data is monitored, for accepting, or for also financing, that people are that different stakeholders are getting together and finance such a project. And it's always good if you get the people with you, because otherwise it's not we know all the project where you have 10 stakeholders and nothing is going on because the one doesn't trust the other one and so on. So if you can provide some transparency planning process, for example, but also monitoring and so on, that's a big thing to accelerate the whole process of energy transition, I think. Yeah.
Is it all about transparency or probably incentivizing those? You've been looking at the residential sector or non-residential sector. Residential sector is probably more crucial. I think you have experience in this field.
Yeah, incentivizing is always a good idea. I know from my personal experience, if you are involved and you don't have external investor who is building something in front of your door or something, but you are involved in it, then you can accept it much better. And I think both goes hand in hand, that you have a transparent approach, that you have incentives, but also like really show the people why we need this technology, why we have to build it, and get the people on the boat. Yeah.
Okay, yeah. One further question I have in mind, and I promised to talk a bit about the ambitions of the energy transition and looking at these fast energy transitions. What are, from your point of view, the most hard ambitions we set for ourselves? So there is renewable integration in place. We talk about heat pump integration, probably refurbishment of buildings. From your point of view, what is the most crucial part of it?
Well, crucial, but also quite easy. Just get started. Just don't think too complex. Oh, well, I want to reach this point in 50 years. That's not going to give you the traction to actually act, to go ahead. Just start easy. Just start now. Technology is ready. You just get a small post box. You connect a small edge device to your building. Back to buildings. You have your first aggregator for this. You have a perfect incentive situation. 3 stakeholders, 3 winners. That's going to be the renter of the buildings. They just pay less for the energy. Although they have to finance the fees for the technology, they still earn money because they're not expanding it. You have the operators, the technical operators, which will win because they have a digital helper to do work for them, which they don't have time for, which is not very valuable if you do it manually. And you have the owner of the building, which gains more value of the building itself, not only by reducing energy consumption, which is important to trade this building if you ever want to sell it or get new renters, but also at the same time, your building is at this point digitized. And now we're back to the topic platform economy. Different use cases. Energy is one use case. And it's a very easy, very fast to start use case. It's about 1 month when you start with our services until you reach about 20% of CO2 emission reduction and energy consumption reduction. But also you get your building digitized, opening it up for any, let's say, room user apps, completely different companies. We are not earning money with this, but we do have application programming interfaces, APIs, enabling the cloud-to-cloud architecture, and therefore different use cases can be included into those buildings, different digitized use cases. So actually there's no reason why wait for anything. And the crucial part is just start.
Okay, yeah, thank you. I mean, there's one more point probably to it. We have seen in the last decade supply chain problems which will come up. There's probably anywhere a congestion towards a renewable energy system. Do we see any burden in the workforce there? Because it's also transition also in the grids. So is there a burden probably in the workforce? What do you think? He says yes. From a grid point of view, probably also talking about the technology.
I think a big problem is the regulation from the government or from every other thing. And so the planning phase of the offshore wind park or onshore wind park is too long. And also the manpower. We need many engineers and workers, and this is also the problem. That we have the project, but we have the manpower that we can build the parks and so on.
But it's no problem for renewable integration in the system and the pace like we do it now, or is it also like there? That the pace has to increase?
No, to integrate in the system, it's not really a problem. That because the grids are, you must shift the load in the grids. So you have lines. They are utilization, and you have other lines. They have no utilization. And now you can shift from one line to one line. So you need control elements in the grid, and then you can handle the energy from the north to the south with this control elements. Not every time, but if you have a 1 year, you can in 90% solve this. So,
Okay. So sounds like we can hold the pace in the grids. So if the grid holds the pace, what is with cybersecurity? Are we ready?
I mean, yeah, back to the cybersecurity, as I mentioned, you just need to have more awareness of that, so that, sure, we are like in this fast transition, we have to more than ever, so we need to integrate those renewables, whether in terms of like buildings, homes, and all of that, but then you would do that with more smart devices, so that you would have this data flow, and then you would use that data for optimization, because that's the goal. You would optimize either your building, home, the energy flow, the shifting between the loads, the generation, and all of that. So it's this whole communication infrastructure, and there's this cybersecurity risk that comes with it, whether you like it or not. So you need to be aware of it and be prepared, so that you would have, if there's an attack, it would not cause any cascading failures on your grid and all of that. So yeah, the risk is there, but it doesn't mean that you shouldn't, and there's no need for digitalization. The good point of it is there, and we need it more than ever, but it's just there's this awareness that has to be there. So yeah, that's what I will have to say.
Thank you. So there is this picture of we're working at the open heart of our economy with this energy transition, and what you said, it sounds quite positive if we remember this picture of our heart and it is worked on. So yeah, I'm quite looking forward into the future and having these inspirations you give us and bring them to the field, especially as you emphasize digitization as one major aspect of it. And I would like now to open the discussion with you. So if you have any question to the audience.
One last point about the workforce issue. Yes, in buildings we do have workforce issues for years. That's why we have very, very low-hanging fruits to just pick from the trees and just feel better. And we're talking about 25% energy consumption to save right away because we don't have the workforce to do it themselves. We proved it even at the university here in Aachen. We had a pilot here, and we're talking about the rollout for the 400 buildings, administrational issues, but anything else. The workforce issue will get worse as soon as we take the next steps about decarbonizing the residual load of energy within this building. That's going to be, in many, many cases, since we're at a new build factor about 1.7% each year, it will take us in Germany many, many years until every building will be rebuilt, and this will even cause even more CO2 emissions. So we are at a good point to refurbish existing buildings, and this is very labor intensive. And at each point, we do not need a complete 100% refurbishment, but we need to throw out those old gas boilers, those old oil boilers, if there are still some left, and we need people to do it. And we see it in Italy, where the residential area is on the run for heat pumps at this point, and they have too many orders. They don't have people to put those heat pumps into place, but also the delivery chain of heat pumps is interrupted at this point, and yes, it's workforce labor already there. Digitization will help us to identify the small parts and the small work episodes where we can invest the time we have and the workforce we have the most efficiently to make the biggest impact possible with these few hours of work.
It sounds like in the energy field there's a lot to do. So for all the students, the energy field, we need workers here. That sounds like it. Yes, so thank you. And now I would like to open up the discussion here. So whoever wants to ask a question to the audience is free to ask. All answers already
so many good questions.
given. But that's fine for today, I guess. I'm not quite sure how many time is left then, but that's on you.
I think we can close this exciting discussion then with it. Thank you very much, all of you, for the exciting discussion. Of course, we have a little something for you as a thank you, so just wait a sec. We don't want you to go home empty-handed, so this is for you.
very much.
And for the both of you. And now, before we start networking, there are also some other happy news to share. Siemens and the Collective Incubator have successfully started their finalized partnership with this event. So yeah, in the coming year, we are looking forward to having Siemens as a strong partner at our side, supporting our vision and working with us to foster innovation and young talents to address global challenges. So thank all of you from Siemens for your trust in our work, and I think you can all look forward to exciting projects with Siemens and Collective Incubator. And now I would like to invite you to finish this event with some lunch and networking. And please also note that some teams from our community have prepared some booths just right behind me, and also Siemens is here with their HR team, and they're going to be very happy to answer all your questions you may have. And yeah, once again, many thanks to Siemens and all the participants for this successful event. And we were very pleased to be the host, and would also be very happy if you find your way again to us, to the Collective Incubator. And if there are some more questions about our work here, we are also very happy